and welcome to episode 5 of our July webinar series on behalf of the New Zealand Hemp Industries Association. This one will be presenting on the circular economy, end uses, high and low tech markets now and in the future. And this one is all about the fibre side of the industry. So we're going to have fibre this week, next week is food, and then there's health. So that's the sort of the cornerstones that the Hemp Association works upon. It gives me great pleasure on behalf of the New Zealand Hemp Industries Association Executive to welcome Elspeth MacRae, who is the Chief Innovation and Science Officer for Scion, which was one of the Crown Research Institutes based in Rotorua. And Elspeth has some of her team from Scion with her as well, so they'll all be participating in the presentation and hopefully get some good Q&A going afterwards. We also have a worldwide, world-famous Carl Martel, who is a hemp researcher and innovator in the hemp industry. Has some really good, interesting things to say about the fibre. So we're hoping that Carl can take us on a bit of a journey into the future as well, and some of those probably more looking at the high-tech end. But it's worthy of note that there's both those aspects, you know, depending on the process. And of course, with our fibre series happening again on Thursday, that's when we'll be talking to about the New Zealand situation with regard to having a decortication set up in New Zealand, and we'll talk about a little bit about the growing of fibre and have a bit of a feature on construction, which is the hempcrete in the building. But today it's all about the circular economy and the where the market's moving to for fibre. So I'd like to welcome Elspeth, and I'll hand over to Elspeth for her presentation, and then we'll come back to Carl. Thank you, Elspeth.
Thanks there, Richard. I'm assuming everyone can hear me, so chat if you can't. And I'm just about to share the screen. So we have a brief presentation. So I'm Elspeth MacRae, from Chief Innovation and Science Officer. I have with me Marie-Jo Guen, who's a fibre researcher, and Mathias Sorieul, who's also a fibre researcher. Okay, so let me try the share. So, and a minute.
You're there, Elspeth? Yep. Good to go.
Good. Okay, excellent. So this is the names alongside me of various people who've actually contributed some information to this PowerPoint. So picture of Scion, the things Scion does, and this is why we think about circularity. So Scion's purpose is enabling New Zealand to transition to a circular bioeconomy by 2030. And that also includes, we're based in Rotorua, very apt, desired Māori impacts of mahi, mana, moni, Māori and mokopuna. And you can see a picture of our campus right at the bottom of the screen. So people will ask, what is a circular bioeconomy? So basically what we do with petroleum at the moment is actually on the left of the screen, we do fossil-based resources, we produce stuff, we consume stuff, and we throw it away. If you start to think about a circular bioeconomy, you start with bio-based resources such as hemp and various other biological materials. You think about the design right at the beginning of what do you want to have happen to your material and how often you can use it and what different ways you can use it. So you minimize waste, and you go through a production, a use, transfer of use, reshaping, recycling, different ways, and ultimately biodegradation, which goes back to the CO2 and water that plants originally capture from the atmosphere. And to do that, to have this kind of economy, you can see in the green part, you see that you've got agriculture, forestry, climate, all sorts of current sectors. But what will have to change is the policies around all of these and more, because being bio means different stuff to being petroleum, and being circular means different thinking to being production to disposal. So Scion has 3 core purposes, targets. It's all about the right tree, right place, right purpose. So the first impact area is about forests that are primarily there for ecosystem services. The second area is about growing, which is like most of the forests in New Zealand at the moment, growing trees in order to make timber or logs or plywood or panel boards. So manufacturing for the built environment, essentially. And today there's a big growth in using engineered timber and using engineered timber for high-rise buildings, so replacing concrete and steel. And then the third area is, which is where for us our fibre work comes into it, and that's bio-based manufacturing and products. So that's really taking trees and other bio-waste, so waste materials, hemp, anything biological, and process it in different ways, manufacture new materials and replace petrochemicals. So that's where our fibre work and our hemp work would fit. So that was about Scion. So I'm just going to talk a little bit about natural fibres and products, basically using wood fibre. So you can see on the left the brown pile, that's lignin. So lignin's the key glue that holds a tree up or holds a stem up. It's the same in hemp as well. And it holds it's the glue, and the glue holds the cellulose, which is that fluffy stuff in the next picture. So under lignin, we've actually got just an example of making nanofibers, lignin carbon nanofibers. So spinning, carbonizing, and making them electrically conductive. So down the bottom, you can see a circuit that's printed with lignin carbon nanofibers. In the middle, you can see what looks like cotton, but it is actually wood fiber, and that, or cellulose in particular. And down the bottom, there's actually clothing from Marimekko in Finland, and so you can turn it into textiles. And then if you look on the right, my right, you can see a process that makes fibre boards. So this is a commodity type product, but actually we can take that fibre and process it slightly differently and add it to plastics and make plastic fibre composites. And this in particular, and I'll refer to it again at the end, gives you lightweighting advantages. So you stop using metal and you stop using some of the other heavy materials and substitute with these, if you can get the performance correct. So what are hemp fibres compared to wood fibres? Well, like you can see, I've got a hemp picture there and a pine picture. And from the bark of hemp, you can actually get long fibres, so they're 1 to 2 centimetres. And from Pinus radiata, the standard pine of New Zealand forests, you get very short fibres by comparison. So again, they're made a little bit differently in the plant. So you can see there's a diagram. This has actually come from the web, the diagram, on where is the fibre. So it's in the stem. You actually go down through various layers further and further into the stem to smaller and smaller, narrower fractions. You can see that on the bottom piece of that hemp section, until you get cellulose, which we just talked about. But you get fibres, fibrils, cellulose. With a tree, you do the same. It's in the trunk of the tree. It's also in the branches and cones and so on. And again, you go down and down, smaller and smaller, till you get to the fibre, which is what you see in the wood, the grain, etc., down to cellulose, which is the carbon part that makes that cellulose fibre. So you can actually see both of them end up with cellulose, and they both also end up with lignin. So what can we do? So we can make pulp out of hemp fibres, just like we can with tree fibres. However, there are some different methods and there are some methods the same. So different methods for preparing fibres. So you see those are hemp fibres that are just more and more magnified as you go across the screen. And there's various things like retting and decortication and screening and decarding and using craft processes, which is what you get your toilet paper from. And mechanical pulp, which is where the fibre boards will come from, for example. And you then process them into different fibre networks, so wet forming, dry forming, and textile forming, so in other words, weaving. So all of the different things that you can also do with pine pulp. And this is just an example of comparison where we've taken the waste from using hemp for various other things, so the residues from hemp stems, and we can make it equivalent to a paper pulp. You can just see some comparisons, and you'll see that the fibre length, for example, is much smaller in the hemp waste residues than you just saw previously. But this is a bit smaller also than the radiata because it's waste, and so people have handled it and managed it and done stuff to it to break it up. So just so to give you some sorts of comparisons that we can use to make pulp. And I'm going to hand over to Marie-Ju now, and this is just to describe the pictures, which is using hemp fibres and products. And this is an example of using PLA, a bioplastic, in a composite. So that's adding the fibre to the plastic instead of having carbon or glass fibre in it.
Thank you very much, Elspeth. So very briefly, Elspeth talked about using hemp fibre into some composite structure, and there was this idea of lightweight composites and also mechanical performances. So the graph at the top are showing you that. Like, for example, the more fiber we add to a composite, the stronger they become in terms of tensile strength. Depending, Elspeth also talked a little bit about rating and decortication. So the top left is showing you that depending on the quality of the fiber, you can get better performances. So it's important to think of the decortication and the rating process when we harvest fiber for mechanical performance. And then the graph along are showing that those fiber interact with the matrix we're putting it in. So in that case is PLA, so it's polylactic acid. It is known to crystallize, and the more fiber we add, generally the more we get some crystallinity, and if we anneal the composite, we can get some better performance again. So that's what you see in the middle graph, where the trend for the fractional strength is going up. There is always a compromise. So on the far right, we can see the toughness. So most of the time, the stronger the composite becomes, the lesser the toughness, which is the energy absorption in a composite. So depending on the application, we want to look at different type of fiber fraction and different type of matrices. But here we're talking about composites which are bio-based and fully sustainable, and then can be composted as well. The bottom graph is showing the difference in the fiber length. So most of the time we would want for reinforcement some really long fibers compared to short ones. The short one tends to be some wasted, discarded hemp fiber that have another use, another primary use, but we can still use them into composites. Thank you.
Okay, so Elspeth back again. So what we have here is just a particular product with being made out of hemp, and the same product being made out of wood fibre. And this is a real product. And you can see as we go across the screen, greater magnification of the surface. So on the top, you can see the hemp. You can see some of the chives or the pieces that are clumpy going right across the surface across the top, and then on the far side you can see those clumpy bits that you can see in the surface of the product. On the bottom one you can see the same thing with wood fibre, and using the process that I described on the making board and panel boards and lightweighting. So you can see there's less large pieces in that particular type of process and that material, but there's no reason why hemp couldn't reach the same performance. So you will have a different performance from both of those. And then I'm just going to ask Marie to come back and talk about this one.
Yes. Yes. So here we're talking about compatibilization of fibers. I talked before that we can change the crystallinity of the PLA matrix or of the polymer matrix we're using. So most of the time when we look at performance problem, it comes down to the adhesion between the fibers and the matrix, which means that we don't get really good stress transfer. So what we have done in the past is to look at how can we improve that. So we often have a matrix which is hydrophobic and fibers which are really hydrophilic. So we try to change that to have a better transfer. The advantage is that we get better mechanical performance with lesser materials. We lightweighting as well. The disadvantage often comes down to the cost. It adds some cost to the fibers, but it depends on the application.
Thank you. All right, and you can see there's a table that lists the advantages and disadvantages of different using hemp to make composites. And Marie just talked about one of the disadvantages, which is the poor matrix fiber interfacial adhesion. So she just showed you that there are some ways that you can overcome that problem. So basically, as I said at the beginning, using natural fibers in composite products is all about lightweighting, and it's all about replacing heavier materials. And this makes, for example, in the automotive sector, it makes cars more energy efficient. They can drive further on their petrol or anything else for that matter. And these are some examples. So you've got a wood fiber plastic dashboard from a particular automotive company using the wood fiber that we just showed you earlier. And then down the bottom, you've got a Porsche with a hemp composite body. So, you know, it can be cool as well as boring in terms of the bits. On the left, you can see some furniture. So lightweighting furniture is an advantage for a lot of reasons, like moving it around, etc. And you can see some bowls that are made with wood fiber. So the two on the outside parts are wood fiber, not hemp. But you get with automotive, you get 15 to 20% lightweighting if you add fibers into the plastic materials as a substitute. And that's it from us.
Right, thank you very much, Elspeth and Marie, for presenting such an amazing amount of information in such a short time. Again, we've been blessed with our presenters being able to do such a thing. It does raise a few questions, and I'm sure we'll get some questions in a moment, but really cool that, well, really good that you mentioned that hemp could be cool. So I'm pleased to see that it coming out. And I think that the end users, it'll be interesting to see what the specification is that the end user or consumer wants in the case of a manufacturing for a car body, and how that affects the production cycle around retting and harvesting and even the crop that we grow. So a tremendous amount of information is going to be required there. So if I could ask you to turn off, have you turned off your screen sharing? Yes, you have now, lovely. And we'll ask Carl to step in and just take us to the next level there, Carl, and then we'll come back for the Q&A. You there, Carl? Here we go, Carl's sharing a screen now. So we're just going to go on into our stop video mode.
All right, I'm just going to, there we go. Okay, so can everybody hear me okay?
Yeah, you're coming through well then, Carl. Thank you.
Perfect, perfect. So I'm going to start with a small thing. This is continuing on with the circular economy. So as I was doing some research, looking at some of the environmental problems that are sometimes associated with agricultural use. And one of them is New Zealand seems to be having a problem with high levels of phosphorus and nitrogen that are running off and then contaminating your rivers and lakes and these sort of things. So I thought maybe it might be good to kind of just go a little bit into how hemp can actually help with some of these problems and how it can then work into a circular economy. So basically I have the problem in the middle. So it's an environmental problem with hemp as a solution in a circular economy, right? So I don't know if I can close off just a moment. The topic board here, I don't know. Just move that over a bit. So soil remediation on agricultural land with high nitrogen runoff. Now, what we can do is plant basically a dual use crop that is basically for grain and fiber. The grain, of course, can go to the food industry side, and the fiber can then be used over here. I use a herd as a mushroom substrate. And from what I understand, you have about in agriculture, it makes up about 4% that and then vegetables make up about 4% of the agricultural economy that you have there. So this would be one place where we could actually use then this fiber into another part of the economy, right? Use it as that substrate. And then after you have the spent substrate, it can then return as a soil amendment to, you know, your vegetables and other things. Now, what I'm going to do next is I'm going to share another screen with you. Just a moment. I'm going to stop sharing this one. Share with, oh, just a moment. Bring up this one and back to here and share screen. And here we go. So that was one part of basically hemp and fiber, for example. So what I've done, and this has actually been published in Hemp Today just last month, in the future of fiber. So as you can see here, I've created a mind map. So starting down in the middle, so it's industrial cannabis, whole plant utilization, okay? And you can see that then it breaks off into different things. So the seed, right? And what can the seed be used for? And I break this all down into its different products and the different things that it can actually go into. And as I go down, you have your seed, you have your roots, you have your flower. And of course, now in Canada, cannabis in general has become rec legal. So we really have whole plant idea kind of going on. You have recreational cannabis, medicinal cannabis, and industrial cannabis, all right? And if we go back up to the top here, you'll see that the stock is where that's broken down into your herd fraction, into your Bass fraction. And then that can then be broken down further into all those other kind of products that you can actually use from that fiber. And that mushroom substrate would be just a small fraction in here, right, of what you can actually do with it. So it really all depends on what you want to do and what you can do, and depending on the economy and the industry and how it's set up, your supply chains. And I guess later on, you know, when we start talking about, you know, decortication, whether large scale, small scale, and how we can really grow this industry, the industrial hemp industry in New Zealand. And, you know, based on the Canadian model, you know, that we actually started at the same time as New Zealand back in 1997, 98. And we began actually with fiber, but kind of shut down pretty quickly when our bales were headed to the United States border, and they were actually headed to Michigan for doing exactly this, the composite panels for car parts. And the bales hit the border, and the DEA said, nope, that's marijuana. And it's like, no, this is industrial hemp. But it took 2 years of, you know, rigmarole and everything else, and it essentially killed the fiber industry pretty quickly in Canada. And then Canada pivoted, and then that's where we actually started going and developing the genetics for the grain side of things. And that's where Canada really grew into, you know, and then having all those different products that you can actually get from the grain side, you know, the food products. Now there's all kinds of waste streams that are actually generated, you know, on the seed side as well. So you have the seed side, and a lot of this stuff that you see here, the vast majority, are all from basically waste streams. So there's really only this one little part down here, right, where we talk about seed and dehulled, and this is really the majority of your industry. It's down over here with your nut, right? You get some oil and some meal, but everything else, you know, you get your husk, you get a pile of things that still can be developed into the cosmetic side of things, and industrial, nutraceutical, and then your whole seed into the seed oil, the meal. And as you can see, there's a large section of things that can actually be developed. And the infrastructure is slowly falling in place. And these are just examples of where all the things you can actually do with a lot of the waste streams that are actually generated from this plant that are essentially waste right now. When you talk about a dual use crop, right, you're harvesting for the grain, and then you still have the fraction, the fiber fraction that's left in the field. And that can be some of the crops. And I know Anka is registered down in New Zealand. This is a plant that can grow anywhere from 8 to 12 feet tall. So you're taking off 4 feet of seed off that plant. Well, you're still left with 6 feet or 2 meters of fiber stock, right? And then that can then be actually, and right now, a lot of farmers just put that right back into the ground. But it can be harvested and then turned into a lot of different projects. One of them, of course, being the hempcrete, a lot of people talk about, or as one I just introduced, is as a substrate. So substrate into the mushroom compost. And from that, though, there's unlimited amount of things you can actually do, you know, from the stock side of things, and everything from the plastics, and not just composite plastics. So hemp has also been demonstrated to be actually aplastic. So we can actually use the hemp without the combination of any other additions of other plastics. So I've made plastics that are pure hemp plastic, both with the stalk, the flower, the seed, any number of things. And yeah, there's a whole range of things that can really be done with this plant, but it's where to start. And that's why I thought, I'll start off really small, show one little example out of this mind map, and then actually transition into this larger mind map. So I think I only have about 8 minutes, so I thought I would just share a little bit of that with you, and then that can then actually then lead to a lot of questions I imagine. There's a lot of information that was given from Scion I thought was very good, and it gives definitely some directions as to where to go. So it now all depends on New Zealand and how they want to actually move forward, and the supply chain that they want to develop moving forward. Thank you.
Very good, Carl. Could I just ask you, Carl, maybe to go back to that mind map and just take us through some of those really, you know, some of the high-tech applications. We've introduced the plastics one, but if you could just go back to that picture you had and look at that left-hand side, and just mention some of those ones about the batteries and the supercapacitors and things. If you could just spend another couple of minutes on that, and then we'll come back.
For sure. Yeah. I could even have put up my battery presentation, I guess, at some point, and I wasn't exactly sure if that was the case. But yeah, let's take a look at that for a second. So if we go to the mind map, we take a look at the stock, right, and then we break that up in basically the herd and the fiber. So I take the herd after it's been separated and decorticated, and that can be done in any number of ways, and some very simple measures as well. So I know you're going to be talking about large-scale decortication down the road, but we can also do this right on the farm. A lot of this I've actually done, you know, right on the farm. It's very, very simple. You know, a wood chipper will do a great job at decorticating. It doesn't do a very good job at separating, but it does a great job at decorticating. Mm-hmm. And then from that material, okay, so we have the herd. Now, you know, we have the construction materials. We know about that. So let's go down to industrial, right? So in the industrial section, then I will head over to, you know, your carbonization. And this is where I actually prepare the materials for battery, for example. So through carbonization, then you have your activated materials, right? That can then be turned into, you know, your electrically conductive materials, gas absorption, water filtration, desalination, you know, and the biochar, of course, can be used as a soil amendment, okay? Your carbon sequestration. Biochar is very, very stable. Any carbon that, any, I guess, plant matter is either agricultural waste or trees as well. They sequester carbon as they grow, but then once they die, they will actually inevitably give back unless we remove it from the field and actually then encase it either in hempcrete or we stabilize those carbons. So these carbons have been demonstrated to be actually very, very stable in the soil for many thousands of years. From Terra Preta, we have archaeological finds that have dated some of the carbons that are still in these paleosols that are up to 8,000 years old. So they're very stable and can actually sequester carbon for a very long time. Now, so those carbons, you know, we can use those carbons in our batteries. So all battery technologies today pretty much use carbon in one form or another, usually though as graphite. So if I take, for example, a very simple battery, a zinc carbon battery, what would be an example of that would be your Duracells or your Ever-Ready batteries, that basically the positive basically electrode in the middle, right, is graphite. And then around that, you'll have a type of paste. That would be your electrolyte. Now, and then the casing around that holds basically the whole battery together, that metal casing that you have around there is zinc. And then you have a reaction that basically goes on and then creates your battery. Now, you can actually replace that graphite, which is actually a mined resource. So it is somewhat finite. There's lots of it, but it is a finite resource. You can replace it with agricultural waste that has been carbonized, which is basically grown from the ground. So we have two options. We can mine it from the ground, or we can grow it from the ground. If we grow it from the ground, that's a sustainable type of carbon. And we can go for a very, very long time, just keep going that way. You know, whereas with a finite resource, once we've mined it all out of the ground, it's gone. And then that material can then be, like I say here, turned into batteries, supercapacitors, flow cell batteries. There's innumerable things, and they all use carbon in some form or another. Even ultimate batteries, which is really interesting. So we have existing technology today, and the Australians discovered a few years ago that when we take a lead acid battery, so it uses sulfuric acid and lead, and this is your traditional car battery. And if you interplate basically carbon between those plates, you don't necessarily increase the power of that battery, but you can increase its charge cycle. So you can go from a normal charge cycle on a battery, which is about 500, and change it to 10,000. So there's a large difference in how you can actually then extend the life of certain batteries just with using carbon. I've made some videos at some point. I should put them up online at some time. And then what I've done is I've actually shown, basically take a zinc carbon battery, and I was showing just the use of, you can go with just the electrolyte and the zinc and graphite, and you have a certain reaction. But then adding in the carbon, you can really amplify the battery, right? So there's a lot of this that's kind of going on, and research that's going in this way. One of the things that I've actually done is create what's called a BIES, and it's called a Building Integrated Energy Storage. So taking a hempcrete brick and essentially put a battery inside of that. And the idea, the concept behind that is to, if you have solar panels on your roof, or any alternative energy source or energy in general on your roof, it charges the exterior of your building, and then that energy is actually stored on the outside surface area of your building, and that can then actually be used as your energy source for your building. So, and essentially the components of that are all natural. So at the end of its life, it can be, you know, destroyed, put back into the field, recombined, used again, and that really speaks to that circular economy that everybody's starting to talk about. And I think it's very, very important. I follow a lot of the principles of green chemistry. So if I can't drink it, I'm probably not going to use it. But, you know, there is a limit as to what we can actually do. And sometimes, you know, we push that line a little bit either way. But I try to actually follow those principles quite adherently. Yeah, I don't know what else I can actually tell you there, Richard.
No, that's perfect, Carl. That's it just gave us a bit of an idea of those fuel and the battery side of things. So thank you for taking the time to move us in that direction. And it's back to the circular economy. It's such a wonderful opportunity to sort of see hemp work in that space, because it naturally sort of fits, because a lot of what we've been discussing is about these waste products. So it's quite a fascinating sort of journey there. There's lots of things that I could carry on commenting on, but there is one question. So I think if we can get onto the Q&A, thank you very much, Carl, and thank you, Elspeth.
My pleasure.
We'll get onto that Q&A. So there's one here. Luke's asked, and I think this one will be for you, Elspeth, or if not, yourself, Marie. Has hemp been used as a feedstock for PLA or PHA production?
There is no reason why it couldn't be. So again, that's thinking about the circular economy and creating biorefineries. So using your waste as a resource for the sugar. So what you're doing is giving the sugar to a microbe, if in the case of PHA, and then you're making the PHA plastic using the microbe uses the sugar for energy. It stores its energy as PHA, and then when you can take it away, but the reason it degrades is because the microbe is also able at some point in its life, if it needs it, to reuse the PHA for energy. And with PLA, similar kinds of things, you can still, if it's just the cellulose, it's the sugar backbone.
Wow. So do you think we're going to have lots of these biorefineries dotted around the country then, Elspeth? Is that the game?
Yes, exactly. And ones that'll probably be able to take not just hemp, but maybe able to mix the feedstocks. So it could be wood residues, it could be hemp, it could be other agricultural like maize stalks, all sorts of things.
And we've always looked at it, you know, the decortication is a classic example of this. You've got a really bulk raw material, so you don't want to freight it too far. That's why these processes, these factories have to be locally situated. And then so you could start off with a smaller version, prove the economics, and then replicate it and scale it up.
You don't even need to scale it up. At the concepts that we're thinking about is distributed manufacturing. So you keep it small and agile. And if you need to, you make it modular. So that's the concept that and it fits New Zealand very well.
It does fit New Zealand very well. That's a classic. That's a very good observation. The other side of that, though, if you wanted to supply into some of these bulk markets, like we were talking about the craft paper for toilet paper, you know, that's our. It's sort of what we can produce is a rate determining step in the sense that, you know, they turn around and say, okay, well, we want 50,000 tonnes a quarter, and we're only growing 5 tonnes at the moment. So we've got this to manage our scale to get up to even providing, you know, the composites for cars is a good example of that. They would have gone a lot further and quicker if the worldwide hemp industry was able to, you know, supply continuously their requirements. So there is a scale question there.
Yeah, it depends on where you want to be. Do you want to be in a commodity or do you want to value add? So you want to be specialist. So if you're a paper, you might want to try to be a specialist paper. And in terms of the supplying of the automotive sector, there's a company called Fibre in France, very subsidized by the French government, I probably can say. But it doesn't matter. They actually are providing waste, if you like, or fibre materials into the automotive sector in a couple of instances.
Yes, because the BMW and the CDC class, they've got quite a lot of their internal panels for the doors and the dashes and things, because it's lightweight, but they have mandatory end of life cycle has to be built into the product being developed. We don't have that in New Zealand. Is that something we should be looking at?
Yes, and I'm expecting it will turn up. Hopefully not in the too far distant future, but basically, you know, this is what we said about the design at the beginning. When you're circular, you have to think at the very beginning about the design of what's going to happen and ultimately how it goes back to the beginning again, if you like.
And because that disposal or reuse, I mean, if it can't be reused, then it has to be disposed of, but people don't factor that into their buying choice because it's not part of the price.
No, so and one of the other things you can do with some of these, so usually when we're talking biorefineries, we're talking about taking, you know, higher value, a lot like Carl's diagram, higher value, next value, next value, next value, next value, and you're left at the end with the stuff that's the hardest. So you can use that for energy as well, to cycle and heat or charge your system so that you're actually still using it. Your material, but it's fully reused if you're not degrading it.
That's it. So but it does come down to, because that would be wonderful if we had such a great supply of in a continuous way, because we're an annual crop compared to, you know, the pine over a longer period of time, so they're more available throughout the year. But it would be just great to be able to sort of break those off into those areas. So, but it all depends on what the end user wants as far as the specification goes, doesn't it? Because then we would be looking at different ways to break the fibres down.
Yes. So if you actually go back to the automotive industry, they have quite rigid rules. They do have to have 95 in Europe. They have to have 95% recycling.
Wow.
So. And so they have quite rigid rules for performance, which are some of the sort of characteristics that Marie-Ju described to you. So performance about strength and various other things. And most products do.
Sorry, that last part?
Most products do have requirements. So yes, you do have to engineer backwards from the product need.
And that will be important for us because we talked about and tomorrow we'll go into a bit of a deep dive around the decortication, which for people that aren't familiar with that term is the splitting of the stems into their sort of bast fibre and hurd or shiv, both of which have a sort of separate market. But you're quite right, Elspeth, a lot of the themes we've had in these discussions so far is not going towards a commodity product, but actually adding value and finding that niche market. And so with the decortication, the step before that, of course, is if you need a retting step, so how that affects the colour and the constituents and things. And then you've got to go back to the plant breeding and say, well, no, we want to breed, plants with higher fibre or a higher seed yield or whatever. So, Carl, that was an interesting thing you were saying around the dual crop aspect. It's still something that, it's up for debate, isn't it, really, whether you go dual crop and try and get these benefits of the waste cycle, or you go for a specific crop and have less of the waste, but still it would be nice to be able to use it in that circular economy. What are you finding in Canada now that they've got a couple of decorticators now? They've restarted their fibre industry in Canada.
Right. Well, yeah, and I'm a strong proponent of dual use. I mean, have been for, over 10 years, 12 years when I started out with Valley Bio a number of years ago. When we first went there, saw the crop, and it's like, yeah, I harvested for the grain, and I still had all that fiber left. And it's just like, well, what do we do with it? I was like, it was a great idea. And the yields were comparable to a single use. So it's like, why not do both? I mean, and you make the modifications to the combine that are very, very simple. Once you know the crop, you can harvest for both. It's not difficult. Even today, though, with some of the latest work that I've done and the whole changes in North America as to what's happening even now, we can use the flower, right? So the combine, we're finding, I can do tri-use crops, right? So I'm harvesting for the grain, but I'm also collecting the chaff. The chaff is then going to extraction, right, for CBD. And then we also have then the fiber that then goes on for your herd and your fiber fractions that can also be monetized. So it's really all about that whole plant that we can actually do now on industrial scale.
Yes, and it comes back to that whole plant utilisations, and that's something that, actually even Elspeth alluded to. The regulatory framework is going to have to change as we embrace these sort of circular economy concepts and start using bio as a resource rather than mining it. And so, in our case, that regulatory framework around being able to access that fraction, which the terminology around CBD and things, but again, potentially a commodity product as well. So there's a lot of value add to be done. And our medicinal cannabis scheme actually sets us up very, very well with the GMP facilities that are required for the medicinal people. So it would be, when we can access that for a natural health product or a nutraceutical, then that quality of production will help us, I believe, in when you're exporting into those high value global niche markets, which can be huge, for a country the size of New Zealand. But I should also just acknowledge that the New Zealand Hemp Industries Association, as part of their R&D committee, does have a food, fibre and health sort of working group, and they've been active in the past. The number of people on the call got a little out of hand, so we've tried to get it back to a steering committee. So after this series is over, we'll pick that up. So if anybody's interested in that, please get in touch with admin at nzhia.co.nz.com rather. But also I just wanted to acknowledge sort of the inherent qualities of hemp, fibre. So this is naturally antifungal, anti-static, antibacterial, antimicrobial, these sort of really big sort of claims. How does that make us fit into some of these applications? Is that something that you'd like to comment on, Elspeth? I mean, naturally antibacterial, so shouldn't all our hospital sheets and our filters in hospitals be made using some of these these natural fibres that have those sort of qualities? Is that a marketing mix, or is that something more tangible in the R&D space that we could really look at and try and make some branded product around rather than commodities?
I think in all cases you will always have to prove the performance for the purpose that you want it. So you'll never get away from that component. And so the expectations of people generally are set by what they have today and what they would like to have tomorrow. So I wouldn't say anything's impossible, and especially if you're prepared to pay more generally. And at the moment, bio generally has to pay more than petroleum, if you like, or mineral, because bio hasn't been around in its current state as long as the petroleum industry. So when the petroleum industry started 100 years ago, it was more expensive than a lot of the bio stuff, actually, that people used to do back in the 1800s. But what's happened is we've had an evolution of a whole lot of new things that you can do and new discoveries, chemicals for antibacterial or antimicrobial and so on and so forth. And so it's time for bio to come back. And so it will be a bit more expensive for most things until we get processes and approaches sorted, and the genetic material.
Right, so just saying that there's plenty of room for study there. Is some of that study going to have to be done at a foundation level where everybody will benefit, or will people that are interested in the industry have to fund all of the study? Is there, how does the government feel about, I'm appreciative that you have to leverage funding, with some industry money, or is that an unfair question to ask somebody?
It's an unfair question, but generally, if it benefits a person or a bunch of people who make money out of it, then they should be paying. If it's something that's stretchier or a concept that's a little bit wider, then it's probably a mix. And if it's really blue skies, then it's ours. Does that help?
Yeah, no, it does. And so it's about the way we couch it, because what we're trying to do here is, we've had 80 years of prohibition, so not a lot of work has been done in this biospace. I mean, the biospace has been growing, but as you described, the economies of scale have all moved towards fossil fuels. So, that's got to recalibrate itself around a new raw material. And we are potentially a good supply of that raw material because we're such a large, a massive producer of biomass in such a short growing period. So we've got a vested interest in getting that happening. So if we can make some moves in that regard, but it's just interesting that, it's now some sort of alignment's happening, isn't it? The consumer wants to move away from some of the issues regarding, the disposability of plastics and things. And so there's consumer, the pull, so industry is starting to get on time, so in tune with that. So it could be quite exciting for something like hemp fibre to come out there being so long and strong. Again, some grandiose claim, which will have to be backed up by science, especially in the New Zealand context.
Yep. And climate change is one of the biggest drivers, and we shouldn't forget about it.
Absolutely, which from our growing point of view then means that, traditionally the observations were grain grows well in the grain belt in Ashburton, but what does climate change mean for that? Where should fibre be grown and things? But again, it's about, local people getting together and forming those cooperatives, about investing in a decortication process or a small biorefinery. And then as soon as we start happening that, then you're clearly we're all convinced that they can be replicated and become part of a larger economy. This is it's a given now, isn't it, really? I mean, this is where we're heading.
Yeah, I think the thing that's changed is through the petroleum industry, if you like, we've actually learned how to make things smaller, how to make things smarter. So 3D printing and 4D printing, for example, less wastage, you can do it on the spot, smaller processing equipment because we've become more sophisticated. So that's what we now need to leverage to be able to do the distributed types of manufacturing, which work for New Zealand.
And is that a problem for us being a natural raw material in the sense that you can really standardise a fracture of an oil and gas, whereas, when we saw the hemp and those composites that you showed with the wood, we were, slubs of hemp and things like that. I guess if we break it down to such a nanotechnology, we probably can standardise it for a feedstock. It'll
depend. So again, it depends on how much standardisation you need and what you want to do with it.
That's it, back to the end users.
You can always do stuff. You can always do stuff. It mightn't always be exactly as you want it, but you can always explore things.
Yep, and we'll just jump to a question from Paul here. Bamboo is a fibre that has been leaping forward in use, which is very true. You see it in a lot of places in uses now. Can the panel component comment, in general, how hemp compares from a fibre point of view, strength, process to make the fibre usable, etc. I guess from Elspeth, you're probably more orientated to the pine. But Carl, do you have any comments on the qualities of hemp in regard to other natural fibres like bamboo?
Well, I really actually prefer hemp to bamboo. I think there's a number of reasons. The processing sometimes for cellulose, for the bamboo, is not always as green as it's touted to be. So I would be careful and cautious in regards to the production methods that are actually used. Now, the same thing can be said for hemp, right? But we do know that there are green methods to process hemp in an ecological fashion. Bamboo is it's a two-headed type of dragon, I think, and it's something that I think that need to really be looking a little bit closer at. But those fibers that we have out of hemp can certainly be as comparable to bamboo as anything else. I think too the fact that we can grow so much hemp, especially if we're going for fiber, the tonnage per acre is enormous, I think, versus many other crops that are out there. And I think that's where the advantages lie with hemp versus other things. I mean, I've even heard of numbers in regards to how much more cellulose hemp yields over wood, right? Over the same period of time that things are grown. I mean, hemp can yield up to 4 times more fiber versus wood. So so we say then, well, maybe we should change our practices of making toilet paper, right? And the toilet paper doesn't necessarily have to come from the long fiber, right? The hurd as well has a lot of properties, and making paper with the hurd card, not necessarily long fiber fractions. So I think there's still lots of room for exploration and understanding of this plant that we haven't really gone into. I think, like I said, I showed you that mind map, but that's only really the start. There is really so much more. I'm just touching a few things there. I mean, it is really so much more than that. But you get lost in the mind map that it can actually do. So it's an incredible plant.
It's very exciting then for the future, because once these scientists and people like the real technologists and the people that are going to move it forward, there's just going to be so much opportunity there for them to do so. But it's a very good point that you've made around manufacturing technologies, because again, part of our approach to circular economy should really consider the impact of those that manufacturing process on our tech as well. Now, Elspeth, you've snuck in somebody with you there?
Yeah, I've got Mathias who can also respond.
On the hemp versus bamboo, bamboo is like fiber is not used as pair, is usually dissolved and reconstituted. So, and this process is not always green, while hemp can be processed directly as fibers directly available, like wood. And so therefore, I think if you are looking for fibers, hemp might be better suited for low tech, because for the bamboo you always need to dissolve the cellulose, so it's complex and chemical intensive process. The chemical can be recycled and reused, but it's not as straightforward. And you mentioned that, yes, we can use hurd as well. And here we have 2 papers. One is made of hemp, and one is made with a hurd. So, no, this one. And it's a very nice paper. So, and for New Zealand, like bamboo grows very well, very fast, and hemp as well. But for New Zealand, the weather is more suitable for hemp. So yeah, hemp has lots of advantage compared to bamboo in terms of fiber, I would say.
Thank you, Mathias, and they're very, very good comments as well. And thanks for breaking it down into that technique of that it needs to be dissolved, the bamboo. But my observation would be that bamboo doesn't have the same regulatory problems that are introduced by the word cannabis as hemp does. So, so in one regard, we've got a product that is clearly a natural fibre bamboo that has made itself available into things as, flooring to pillows and whatever. But it's showing that you can do those sort of things, and there's manufacturing that can keep up with that. But I don't, but we will get there. But we've just got this regulatory hurdle around the word cannabis. Carl, you wanted to comment?
Well, yeah, in regards to the regulations, I think this is a question of education, right? If we have to educate our lawmakers, right? Make them aware of these things, and then show examples of other nations that have done this, and have done this in a responsible way, right? Moving forward. I mean, I think Canada is really a shining star when it comes to this. We started with industrial hemp, and now we've gone all the way through to industrial cannabis to recreational cannabis. And guess what? Everybody's not getting stoned. So, I think that's the message we need to get through. And we need them to understand that, marijuana is only that one small little part, whereas industrial cannabis is everything else. So we just got to get that message through and have them understand that, if you grow this product, your population is not going to go crazy. And I think it's just a question of time.
Yeah, thank you, Carl. And from a New Zealand context, we do have a referendum in September at this year's election around the use of adult use or recreational use of cannabis. So, and you're quite right. I mean, all of this problem associated with the psychotropic THC isn't a problem for us as an arable crop. So we're just working through as an association on our approach to that, and we'll be contacting the members for their feedback post our AGM, which was last weekend. And the outcome of that is we need to ask our members directly, should we be supporting that? And if we do support it, it's not about the personal choice of whether you vote yes or no. It's about broadening that conversation to say, hey, this is about the cannabis industry, and industrial hemp's a big, big part of that. And with that, fibre is a massive part of that. Now, the reason why we don't have a lot of fibre industry in New Zealand is because we don't have that processing step, that decortication. And you're quite right, Carl, I've got umpteen bags in the container of stuff that's come out of a chipper, and that's fine, but you do need to split it into those raw materials to really get using it in an industrial sense. So I'm really pleased that Scion's always shown an appreciation for hemp. We should also acknowledge some of the other people like Professor Kim Pickering at Waikato University, who's had PhDs working on this since hemp was first grown, and even during the trials in the early 2000s. So she's got a whole shelf of PhD work. So it can't be too far away from us being able to use that information. And of course, we don't have a massive automotive industry in New Zealand, but we do have a very big yachting industry. So, Elspeth, maybe you'd like to comment on that. How can we get hemp into the America's Cup or some such thing?
You're quick. We'd love to do that.
Well, we'll sign up. We'll get the funding for you to come up with the latest carbon technology using natural fibres.
Yep, so we do have some technologies right now that we were thinking would apply into that with the lignin, using the lignin carbon nanofiber with electrospinning, but I'm sure there's some other routes we can look at as well.
Right on. And there's lignins, just, again, a byproduct. That's the glue holding it together that we're trying to get rid of so we can split it up. And then it's suddenly, you're just describing how that's got a market for some use as well. And would it be fair to say that, we're just sort of, as Carl was alluding to, we're just scraping the surface of what can be done when we start reorientating towards, sustainable raw materials like natural fibres?
I actually think that's true of a lot of the things we use, especially in New Zealand. I think we're quite wasteful compared to people who way back in the 17 or 1600s started using different materials and different plants. So there's a lot more resource there to be tapped, I think, in general, not just with hemp, but in general. Yes,
and so we can learn a lot from that past use and that using using the whole plant utilization, because they wouldn't have thrown anything away. If they've been bothered to do something to process it, they're going to use every bit of it. And that's the sort of mindset that we need to get back into. And I think possibly the new normal, we'll be talking in the terms of the new normal post-COVID, this is another bit of a wake-up call. I mean, we're looking at now packaging materials and supply chains and what we can do in New Zealand to make us a little bit more, secure in our supply chain. So, I think these new questions, these new ways of looking at things have to be discussed more.
Yep, agree.
Very cool, very cool.
Well, absolutely.
And it's a conversation happening around the world then, you would agree, Carl? People in Canada are thinking similarly?
Oh, yes, absolutely. We've been having very similar discussions in Canada in regards to all that. So, and re-examination of a lot of these things. Because, yeah, we saw that COVID had some problems. I mean, we ran out of toilet paper at the same time as Australia did. I don't know how that happened.
Yeah, and people without toilet paper, that could get messy. We've talked a little bit about the high-tech side of things. Can we just talk about some of the low-tech? So what I'm thinking there is insulation materials, medium-density fibre boards, and we've got infrastructure in New Zealand to produce some of those, Elspeth, the Fletcher building and Laminex and things. Are they starting to look into that space as well? Are they encouraged to start using natural fibres?
Yeah, companies like Laminex do have like a sustainability approach as well. But at Scion, for example, we've produced some medium density fiber board out of wood, but as well some particle boards made of hurd. So like this type of low tech, and we could use like any hurd to make those medium particle board. So yes, like there are like a diversity of product that can be made out of some low value parts of the plant, like hurd.
Right, so there's two things in that space. We need to work out what the price we can produce it for, and is the existing mechanical process or machine that they have able to do it. And I think the answer to both of those is just definitely we can possibly do that. So it's going to be some exciting times. We've got to reach out to those fibre people in those industries but again, even them, as Mathias is saying, they've got sustainability departments now and things. So there's actually an opportunity for us as the hemp industry to make that happen. I think acoustic tiles and all sorts of things in the construction side would be a good first step to get those lines of supply going. And then as you can scale up to the more medium density fibre boards. That's great stuff. It's been a very interesting sort of all over the fibre side. Thank you guys for being part of that conversation. Before we finish off, is there anything else that you would like to add or in your case, Elspeth, the team with you, is there some things that, some little gems you'd like to share that we should be thinking about that would make it all happen for us?
No gems. We've also got some woven hemp material here that we could show like that, but it probably wouldn't help. But we do. So we do work quite a lot, and we also do work with the chemicals as well, and the chemicals that you can get out of it. So yep, we think there's a lot of potential for parallel types of applications as with wood.
And that's a very important point around what hemp represents to the primary industries in the sense of a complement, because I've made some socks that are just wonderful with New Zealand wool top and with a bit of possum in there as well, or even going right up to merino. So New Zealand hemp with our wool industry, with our forestry industry, there's a lot of complements in there. And when the PGP sort of changed their name to the Sustainable Food and Fibres Futures Fund, clearly that's just named straight after hemp, because we've got such a great thing about fibre and food. So, everybody's waiting for hemp to arrive.
It's the wonder plant.
Okay. But that complement really does work for us because we're a rotation crop. We want to work with the other significant industries and just be part of our New Zealand, the success of a New Zealand, another successful New Zealand industry, as has wine in the past and kiwi fruit and honey and things. So there's already a blazing trail. But Carl, is there anything from your point of view going future trend wise, where the industry is tracking? What are, you know, we're going to have to move away from the high grade papers and horse bedding markets, which have been the traditional markets. Hempcrete's starting to gain a bit of traction. We've talked about the cars. Is there anything else on the horizon though that is exciting?
Well, you know, now that CBD buzz and everything else is kind of toning down a bit, you know, I've been able to actually sit down and look a little bit more and focus. I think there is a lot of low-tech things that are coming. That, you know, for example, you've heard of goose, Canada Goose jackets, you know, and they use a downfill in there. Well, you know, those fibers that we're talking about, well, they have some great insulatory abilities. You know, we talk about non-wovens and these sort of things. That we can also incorporate, for example, those fibers with wool and do these composite with wool fibers and create all kinds of clothing. So I think, you know, the future is very bright for low-tech and high-tech applications of this plant. It's just a question of, you know, moving things forward. And I think, you know, the forward is very bright, and who knows in which direction it can actually go. I mean, the flower's only just touching certain things there, but I think we're learning a lot more. You know, one, for example, is quinones that we can actually get from the CBD. Well, while everybody's been looking at quinones for CBD, I've been looking at it for industrial applications, you know, and I think that might be another channel. As the price of CBD comes down, you know, we could be looking at that. And quinones and graphite, we know, makes a green battery, and these would be in the flow batteries. And I think this is one area where I'm going to be looking a little bit more closely at as I can continue my research and move forward. It would be kind of into some of those areas there. I think, yeah, and I think there's plenty of things that we
that's it,
still yet to come, and who knows where.
That's it, and this is what's going to make it such a that's going to add the continuity to our journey, because there's going to be so many things. Elspeth, you and the team at Scion are just going to be busy on this for years and years to come. And hopefully with the associated funding and things. Low-tech uses, you mentioned the non-woven, so that's, you know, the matting off the side of the motorway. But I'll leave you with an interesting one around asphalt. You know, putting a little bit of hemp fibre into asphalt makes the asphalt last longer. So, you know, when are some of these roading people going to say, oh my gosh, let's do a study on that? Because if that is the case, then, you know, if you can extend the life of a road, they know how much that is worth to them. And I think hemp, when it starts to get used in those sort of equations, is going to really light up quite a lot of opportunities. And that's why this series is a little bit around creating those light bulb moments for industry. So if there's people listening from industry, heads of industry in particular, you know, think about how you're going to incorporate hemp fibre into your business plans, because it's coming. And if you're ahead of the curve, it's going to really serve you well to be aligned with natural fibres and the circular economy and things. So in conclusion, I'd just like to say thank you very much to our presenters, Carl Martel from Canada, hemp inventor, and we look forward to hearing more about the inventions. And, you know, there's lots of good things coming out of Australia in that regard too. And Elspeth MacRae from Scion, and the team that you brought with you as well, Elspeth, thank you very much for sharing your knowledge and what you guys do. And I think there's a hugely important part to play for the Crown Research Institutes and our universities, amongst other scientists and research and developers, because this is the beginning of a long and interesting journey. So thank you very much for joining us. It was a pleasure to have you here.
Thank you.
Thank you.
Thank you. Bye.
Thank you very much, Richard. Thank you for the opportunity.
Okay.